Hi guys, welcome to the channel Code by Raghav, and in this video we are going to solve the LeetCode question number 69, that is square root of x. It is an easy type question and it has been asked by many interviews. As you can see, the big name here also: Amazon, Lyft, Apple, Microsoft, Google, LinkedIn, Uber, Facebook, Nvidia, Morgan Stanley, Goldman Sachs, Samsung, Infosys, and many more. So, this question checks your fundamental skills. How do you approach this question? So, let's read the statement of the question and let's see how we can solve this question. So, we have given a non negative integer x. Return the square root of x. Round it down to the nearest integer. What is rounded down means? It is just return the previous value, means the square root of 8 in this example is 2.82 something. Now you just have to return the rounded down value, that is 2. So the return integer should be non-negative as well. Okay, you must not use any built-in functions, so we cannot use this power inbuilt stl function. So let's see how we can solve this question. As you can see in the example 1, the x is 4, the square root of 4 is 2, so we have to return the 2. In second example, x is equal to 8, 8 square root is 2.8 to something. Now we have to return the rounded down value, that is 2. So let's see. So first we have to minimize the irrelevant information. So was the irrelevant data. So if the value of x is 0, so a non-negative integer square root cannot be equal to 0. You can take any value. Root 1 is 1, root 2 is 1.4 something. So a non-negative integer root, square root, will not be equal to 0. So it's not need to add this condition for the 0. But in the constraints, if you read, the x is greater than equal to 0. So you can add a condition: if x is equal to 0, so return 0. But I have tried the solution without this and it works successfully. So don't need to add this. Now we got our 0 as the starting point. If we point this as a number line, so the starting point is 1. We are not taking 0, sorry. So what the maximum value it can be? We have to search it through. So if you know, any root of value is always be less than equal to the x. The square root of x is always be less than equal to x. So this is your main important point. So the max range of this number line will be 1 to, if we take this question, let's say 8. Now we have got our the starting range and the max range, so that is x. So for this question, that is 8. Now we got our range, so 1 to 8. Let me write down: 1 2 3 4 5 6 7. Now how would you solve it now? Let me copy it. Now how would you solve it? Now you have two approaches. One is linear search. Go from 1, search it for the, if nums of I into nums of I is less than equal to the x, that's it. You have to search it for, so you are searching linearly, so it will take the time. Complexity will be O of x. So instead of that, instead of linear search, we apply what we have learned so far, that is using binary search. That is, remove the extra search space. Means if we got something that is, let's say, value, if it is bigger than x, so what's the point of finding after this x? Let's say 4, 16. 16 is greater than the x, it can be square root of 8. So what's why we search for the rest of the array? So we will remove this search space, so we will focus only on this sub array. So that's how this binary search. And so let's try to implement the binary search. Here we have not the indexing, we have just the numbers from 1 to 8, so we can use them as a index 6. So the low will point as the 1, high will point on this 8. Now we run our condition, that is L is less than equal to H, that is our default binary search template. We have done so many questions that changes this condition, but we start from our default template and we will modify from there. Now we find mid. So what will be the mid? 8 plus 9 by 2, that is 4. So mid will present here, it will point this 4. We got our mid is 4, and the value we have to search is 4 into 4, that is 16. Now we check if 16 is equal to x. No, it is not. So the second condition will be else if. Is 16 less than the x? No, it is not. Next, the last condition, is 16 bigger than the x? Yes, it is bigger than the x. So what we will do? So we have to remove now this right half. So we have to remove this search space. So what we will modify? We will modify this our h pointer. So it will come over here on 3. So it will point on 3. So in the else condition, we write h is equal to mid minus 1, and now let's, our h comes here. Let me erase this. Let me erase. Now we have minimized the search space on one iteration, this much. That's the advantage of using binary search. Now we find the mid again. What we will get, the mid we will get is 2. So the value will be 2 into 2, that is 4. Now we check, is 4 is equal to x. What is our x? That is 8. No, it is not. Is 4 is less than the x? Yes, it is less than the x. Means our target that we are searching will be on the right side. So what we will update? We will update our low pointer. What we get here? 4. So L equal to mid plus 1. Now we, so mid L will come here. Now we again calculate the mid will become 3. 3 into 3, that is 9. Is 9 is equal to x, that is 8? It is not. Is 9 is less than the x? It is not. Is 9 is greater than the x? Yes, it is. So we have to update. As you can see, we have to one more iteration we are doing because it is less than equal to h. If we do not do this, we will get our answer is that is 3, and 3 is not the answer because we have to do the round round it down. So we are doing the less than is equal to condition. Now the h will move backwards, mid minus 1. So h will come here and our condition breaks. Now the answer is lies on our h pointer. So we will return what? Return h. So that's our answer, that is 2. And when we get in this question, in this example, as you can see, x is equal to 4, that is direct square root without any, now without any rounded values. So we will return the directly mid for this condition. So that's our basic binary search template. We have to do nothing, we just have to find the, we have just got the understanding how we get the search range. That's the important point of this question. So let's try to solve it. And so the low will be start from the 0, high will be x, while low is less than equal to the high. Now we calculate int mid, low plus high minus low by 2. Now we have to calculate the value. If you do int value equal to mid into mid, so mid, this value can overflow the int range, so we have to take this as a long. If we are taking this value as a long, so we have to take this mid also as long. Now we write conditions. If value is equal to x, return mid. Else if value is less than the x, means we have to modify our left pointer, mid plus 1. Else if value is less than x, mid plus 1. Yes, that is correct. I always get confused. That's why dry run is very important to verify your conditions while writing code. And high will be mid minus 1. And what we have to return? We have to return the high value. Let's try to run it, and as you can see, we have passed the test cases. Now let's try to submit our solution. And it is taking time, and we have passed the solution, successfully accepted the solution. So thank you for watching. Make sure you like, share and subscribe. Thank you.